I'd like to request all of you to please welcome on stage Gangadhar Gude, co-founder of INVECAS.
That's great. Yeah. So unfortunately, this was not supposed to be presented by me. Our CEO was supposed to be here. He couldn't make it. He gives his regard. I hope I don't screw up on his behalf. So to start off with, INVECAS is a chip designing company. We're an IP company. But this is a different take on topic. We're talking about the generation of AI, the next shift in generations completely. So to start off with, I'd like to go get a little personal. I'm very casual, don't mind. What is the past? Let's talk about me. I'm 30 years old. 2 decades ago, when I started out with gaming. Gaming is something that was very sweet to me. Nintendo 64 was my first gaming console. Contendo was the first game that I played. From there, look at the shift of what technology has been playing a role, what AI has been playing a role. You look at it today, if I play a single game, it used to have a single ending. The same game, I can have 30 different endings, 40 different endings, and I can keep on playing that. So, I mean, how many of you guys know Doom? The first Apple product had Doom. That was the biggest played PC game back in the day. And now 2 decades later, Doom still exists, but in using AI and multiple functionality. From there, we have moved all the way to a product called, which is introduced by Microsoft, HoloLens, Augmented Reality. This is where I can go anywhere in the world, any place, watch TV wherever I want, play any game I want, anywhere. And how is this being connected? How is AI, artificial intelligence, playing a role in all this? Augmented reality, virtual reality, gaming. Again, very sweet to me. Gaming today, as such, let's take the VFX. Every single game has over 1 million pixels that are being generated for a single screen. But when the output comes, it's 1080. So what is the technology that's able to bring all this into a 1080? Again, artificial intelligence. This is where, for me, gaming has been very sweet. It's an industry where, as all, technology adaptation has always been there. This is one industry where the technology, whatever the latest technology, keeps on coming. It's being adapted by this gaming industry. One of the biggest things, which I just wanted to give, we came out with the first HDMI 2.1, and already Microsoft Xbox is integrated into their system. It's really a snap of the finger. That's why this industry has been very sweet in adopting newer technology, newer shift. And take all this. I just gave a small brief about the gaming industry. A lot of people stated gaming industry is going to be a dead industry. Gaming's been there. The number of gamers are the same. It's not going to change. But if you see the shift from 2016 to 2020, there has been a growth of 6.2%. And look at the mobile gaming, PC gaming, console gaming. There's been a tremendous, tremendous shift in this. And what? It's a smart mode shift. And what is your smartphone? Your biggest AI engine. That's what's happening. What are we going through today? What's happening? What is all this AI? I mean, here we're at IESA. IESA is like, okay, how is this AI changing our future? Everywhere we go, we're hearing the buzzword AI. AI. Some people were asking questions. AI is going to replace my job? That's a big question that we get nowadays. AI is going to replace what I do as a living or my lifestyle? No. There are different ways of doing this. And let's talk about this AI revolution that's going on. In the last couple of decades, there are different revolutions that went on. Green revolution, industrial revolution, and now AI revolution. What is a revolution? A revolution is nothing but, let's say, it's breaking barriers. It's breaking constraints. So we are facing something. To tackle that, a revolution comes in. So going back to that, I'm going to go to the next slide. What are we solving with AI revolution? As we know today, the global population has been increasing exponentially day on day. And one of the biggest things for this is food. How much food do we need to feed all this population? So we have our factors. We're being limited by the land. We're being limited by the number of resources that we have. Yet, we need to have enough food to deploy to people. AI-powered agriculture. That's improving yield. Next, language barriers. Today, we're talking about this as a global economy. We all work globally. China, Europe, North America, South America, India. But we all speak different languages. So how do we tackle all this? One example that I can give. I know Google is legally not allowed in China, but there's a way we can use it. I use Google Translate every single time I go to China. I go type in here. That's an AI functionality again. Next, we're talking about smarter, safer logistics to connect, smarter transportation. In the early 1900s, we used to travel by ship. It would take a month or two to go from one continent to another. Today, we can travel the world in one day. That's a huge. And how is this smart? All the flights, there's many flights, aerospace, that are being driven by themselves. Pilots don't control it anymore. That's AI. Last but not the least, which I feel is a very, very great achievement on behalf of AI as such, is Bionics. Bionics is something that as a limbs or functionality for human beings to be able to do things regularly with the support of robotics and AI, and something which I felt more personal. That's why I thought, okay. So these are few things that I listed that are solving the real world problems today. So far, all this AI revolution has been being driven by software. One of the biggest questions that I keep on hearing from multiple people is, and especially IESA, where is the hardware? Everyone is doing the software. It's all software, AI. The minute I hear AI, people are like, yeah, that software is amazing. The algorithms are amazing, and it's software. But I believe it's hardware. And moving on, I want to list why I believe the future for AI is hardware. What are the few things? Today, we're building platforms, we're building systems, compute, to be able to enable this AI. What are the basic things that enable this AI? One is the high-speed computing. There's a lot of data that's coming out, so we need something to process the data. 2, the connectivity. We're global, we're located in multiple places, but we need real-time understanding. So how's the communication going? 3, devices, smart devices, which can relay this information from place to place. But we're coming back to it. The current generation of processors that are being used for this were not meant for this. The GPUs and CPUs that we're using were never meant for this application. So one of my favorite sayings, we're a custom house. We do custom ASIC. The same glove does not fit all hands. This is where AI is going to have multiple custom chips. Why? We're talking about AI for autonomous driving. We're talking about AI for facial recognition, smart surveillance, behavioral, retail. You're talking about multiple functionality. And moving on to the next slide, I just wanted to give you a basic map of where you see why we need different custom silicon for these AI applications. So talk about translation for speech, talk about facial detection, talk about planning optimization, talk about pricing. Everything is very price dependent. If it's expensive, why would I want to go for it? So how is this dynamic? And all the depending factors, it's computation, power, the amount of form factor, how flexible. These are multiple factors that make what the custom AI we're talking about. That means, again, different silicon. Yes, I'm talking to you guys. I'm telling you, yes, we're going to do this. This is what's required. Is there a market? Is there a market for this? Is there really a market available for this? So I picked up two. One data centers and one is edge computing. Let's take these as examples and talk about in the whole global market. Let's take these two. Let's take these two and talk about this. 2017 in data centers, we're talking about inferencing and training. Okay? Inferencing, if you look at it, I have ASICs, CPUs, GPUs. The change from 2017 to 2025, and this is by McKinsey. These are information by McKinsey. Look at the need for custom ASIC. It's increased almost by 400%. Excuse me. Just in inferencing. And look at in training, where it was nothing, practically nothing, to almost 50% of what the market need is. Let's talk about edge. Edge is something which is relatively new. People say, hey, it's something new we're trying to work on. We don't need it. Look at the need for custom ASICs, custom silicon, custom IPs. All this is again powering AI. Again, extending onto this. Now I showed you the percentage of the markets. Let's talk about the numbers. Okay? What is the numbers that are there available just in data center and edge? 2017, it's $4 to $5 billion. 2025 is $9 to $10 billion completely. In training, it's not even one. It was never there. Training is something new, but look at 4 to 5. Similarly, in edge, again, as I said, is a very new concept. Around 100 million has been done. And within 5-6 years, we're talking about $5 billion. So this is, again, going back to the theme, we're talking about the $4 billion market. How is hardware playing a role in this? How are we as an AI playing a role in this? This was supposed to pop differently, but backing up that information, the biggest confidence that we get from different people is where is the investment firms, the venture capitalists putting their money in. In the last 1 year, AI-driven semiconductor-backed companies, the investments have been $113 million. That's the number that was funded just last year. I don't know how many of you saw Wally's presentation in the morning. He broke down on a quarter to quarter, and you saw a huge spike in third quarter about how much money is being invested into AI-driven semiconductor companies. That's huge. And just to give you a relative, over the last half decade versus just 1 year, it's 500% difference. It's 5 times more. There's qualification right there. So let's move on. We're talking about, okay, you're talking about AI. No, there's enough business. It's a saturated market. There's a lot to do in semiconductors other than AI. How much is this growth? So to put into that relative numbers, okay, that's where we went. Again, all this, there's McKinsey and Gartner backed information. AI versus non-AI. The statistics show year on year, the growth for semiconductors is 18%. 18%. By 2025, the AI contribution for the whole market is going to be 20%, just by itself. For semiconductors, and here, this is pure semiconductors we're talking about. 20% of the whole market share is going to be AI. Today, I don't think other than compute, no one owns that market share. That's huge. That's like, where did this suddenly come from? I mean, AI that I know was always software, but we believe it's hardware. Hardware is going to make the differential now. And this is information, again, to back that up. So what did we need? Now, okay, all that is there. We know the demand is there. The requirement is there. What is it that we need to do as a hardware or a semiconductor industry to be able to contribute towards this? What are the IPs that we need to do? What are the capabilities that we need to do to be able to showcase this? So, opportunities as a global platform. Compute. We need to be able to build the AI accelerators that are required for it. Memory, DMA, NVMs. These are huge now. Memory is picking up very crazy. At one point, we were hearing, hey, memory is dead. Semiconductors, we don't need any more memory. Now that is what all is required because everything's about data. How are we accelerating this data? Storage. How are we storing this data? Network. How are we communicating this data? These are the things that we can work on as a semiconductor industry, as IESA, as a global ecosystem for hardware. Yes, this is there. We're also talking about how many jobs that are being created. We're talking about there's a need of 2.3 million jobs just to cater to this market. At one point, people were stating, hey, semiconductor market is saturated. There's no more life. Suddenly just started booming up. What's driving this boom? What's driving this change? What is this required? And one of the biggest questions as us, Indians, and I keep on stating that, how are we going to benefit out of it? What is it that we get? Okay, you spoke about all this. You're speaking about on a global platform. This is what's required. This is what's there. This is the total available market. This is how much the VCs are putting in there. But how does it make sense for me as an Indian? As an Indian company, as an Indian engineer, what do I get out of it? China's driving the AI wave. It's no longer North America. Where do we stand? We're right behind them. So this is where we have a huge open platform right in front of us to take whatever we want. We're talking about the computing and the chip capability. That means from custom ASICs to custom IPs. Cost versus performance versus price. These are things that we can do. Another, the job opportunities, skill capability is very high in India. We need to maximize on that. Startups. How many institutional investment firms are coming to India? How much investments are going in there? How many ideas are being picked up? We need to work on that. And all together, summing this up, this is where we work with IESA to bring out all these technologies. This is what we can take. This is the platform being served to us as Indians. I put it in there, infinity. Nothing is impossible. There is no dead. Infinity was invented by Indians. Again, coming back to this, I wanted to say, there is nothing lost. There's an infinite number of possibilities. I like to leave off saying, hey, this is a very huge availability for us. We believe custom silicon, custom IPs, AI is the future, and there's a lot of possibilities. It's in our hands what to take away. Thank you. Any questions, or do we have a Q&A? Any questions? I think we have time. Yes. Oh. Sir, Mike. Oh, sorry. Thank you.
Yeah. Good evening. First of all, I like the perspective you mentioned. AI is not just necessarily a software, but it's a hardware. That's interesting. And the hardware side, the silicon side, is INVECAS doing any in that direction, or do you know any Indian company? I'm not talking about the MNCs, right?
Right.
So any example or anybody doing that?
So we at INVECAS are building custom AI chips. We already have built an ADAS, autonomous driving chip. We already built a smart chip for facial recognition for
Your own
image
IP
sensing.
or for somebody?
I'm sorry?
Is it your own IP or for
So
somebody?
it's our IP, but we're building a chip solution for another customer. But we do have a lot of IPs in-house. There's also another company that we're building edge inferencing chips already, which is a competition to the GPUs available in the market. So in that sense, is there work being done? Yes. Is it come out into the market? Yes. But the potential is very high. There's more of the market available right now. There's also, like, take Alpha ICs. Take Netrodyne, which is a system company. There are many companies that are out there, ETAI. There are many companies, Indian companies, doing this as hardware or silicon level.
Interesting.
Yeah. It's a very different take. I mean, people told, when I was like presenting, I was like, you guys don't know, these are numbers. These are actual numbers. I hope that answers.
Yeah, interesting.
Yeah, I think my question was related to that. Since you said you visit China a lot, okay, is it possible to give a comparison of where you think China startups are in this AI, IP and processor building and where we are, and and
So-
what is the scope of IP building, because is this just a, it's a, like, is the opportunity that you make specific accelerator for specific applications, and then requirement of hundreds of IP that can be built around this?
So to put it into, there is an AI startup every day in China that's coming up right now. That's ridiculously huge. We were very shocked. When we went out to check what are the possibilities, I mean, today, just from the AI community in China, we have over 100 customers as INVECAS. And yeah, we ourselves didn't realize it's going at that pace. Let's take it to India. I can count on my fingers how many startups are there. It's not that we don't have the ideas, it's just that how do we guide people to come out with these ideas? That is the biggest gap that we are facing. Whereas China, as a government, as a complete ecosystem, as a community, is pushing them. All these startups, 30% to 60% funding is done by the government to come out with these products. We don't have that. But as an ecosystem, there's huge potential, which we should know how to capitalize upon. I hope that answers. Yeah.
And other thing is that there are hundreds of services company in VLSI design, right? Okay. So when you looked at from the AI requirement, okay, what are the core competences they should have to address this AI opportunities? Is it just they should be good memory designers, or they should be good in I don't know. Okay, I'm just asking this.
So,
question.
going back to the AI enablers, memory is huge nowadays. So if you're able to build good memory chips, that's number one. Number two, computational chips. Today, high computation is associated with GPUs. GPUs does not cater to this market. You need a custom tailor to this. So I can't say pinpointed this specific engineer will grow, but as a whole semiconductor market, it's going to grow. Because you need more custom chips. You need more custom IP. IP in the sense, not just memory, even take PLLs, GPIOs. What is the requirement for these tailoring? In between, we had the Bitcoin, the cryptocurrency wave. That's actually boosted up the whole thing. That was made for AI. So in that sense, I can't say, okay, this is the specific thing. But as a semiconductor, there's going to be huge growth. But custom ASICs, custom IP. There's not going to be generalized anymore. Yeah. Any other questions? Oh.
So what I have seen actually is, whatever CPUs that were designed long time back, similar kind of architectures or similar kind of approaches are being taken for new kind of requirements also. But I don't really see anything, some kind of shaking kind of a different shift in architecture.
Right.
We have retrofitted whatever existed for all the new types of requirements. So is there something that's happening in that direction in the country? For example, in India, are there research? Is there research going on in terms of how do we redefine this complete architecture for new kind of workloads and things like that?
So one of the biggest architecture risk 5, is they're hoping that this is going to help support from a processor architecture standpoint of view. Within India, I know only one company that I can talk about, which is Alpha ICs, which is working in a different architecture for computation for AI. But even in computation for AI, like I was stating, different application has different requirement. If you look at whatever has been being developed or what is being showcased, they're trying to get to the market quickly. The best way to get to market quickly is retrofit. But is there research being done? Yes, there is research being done inside Harvard, Stanford, University of Toronto, in different architectures, especially for facial recognition. Computer vision is a huge field that I know inside Stanford, they're funding almost $500 million just for different on hardware side. So it'll take some time to come into the market, but whatever you will see in the market in the now, it's going to be all retrofit architecture. Yeah. Any other questions? I guess, thank you. I hope I didn't make a fool of myself. Any questions? Offline. Thank you.